Welcome DC Circuit students. In this video we're going to go over the basics of how to use a solderless prototyping board. And here is a solderless prototyping board. This one is a little bit fancy in that it has what's known as rails connections on both sides that are connected a little bit differently than the middle portion where you would build your circuit. So the important thing to remember about these type of prototyping boards are, first, you don't have to use solder to connect your electronic components. Each of these little holes in the board has a tiny spring clip that's meant to basically grab onto the end of a single strand wire. So if you have your insulated wire, you strip off a little bit of one end, make sure it is single strand, not multi-strand, and then you can carefully just insert the wire right into the socket and it's connected. So to build a circuit, the important thing you need to know is which holes are electrically connected to which other holes. And the basic way that this goes is each of the holes that's in each numbered row are all electrically continuous. So each one of these holes in, say, row 18, they're all connected to one another. They aren't connected to any of the holes in row 19 or row 17. So most of the prototyping boards have some lettering and numbering so you can keep track of where your components are plugged in your circuit. One of the biggest mistakes people make is to accidentally plug something into the wrong row and then think something's connected when it's not. Now, if your prototyping board has these colored rows on the ends or on the sides, these are known as power rails. So they are all connected to one another along basically a column. So all of these holes that are adjacent to this red strip, they're all electrically continuous, likewise with the ones on the blue strip. This board is basically a 2-in-1. So all of the power rail sockets on the upper portion of the board are not connected to the ones on the lower. So we kind of have the ability to separate circuits and build a couple of different, or maybe 4 different. Likewise, holes that come across the center line are not connected, even if they're in the same numbered row, and the same with rails. Now, if we're not sure that that's the case, we can always use our multimeter and use our grabbers and grab onto our piece of stripped wire and make ourselves a little protoboard tester so we can test for continuity. I don't have the sound on my multimeter, so we're just going to look for basically either an overload, meaning we have an open and sockets are not connected, or of course if they're connected we'll get a very low reading about the resistance of the wire. So we're going to start by ensuring that the sockets along this row are connected to one another. So I'll put my one lead at one end and I'll put the other at the other, and notice that I'm reading basically negligible resistance, and I can do the same with any one of these positions along that red row. But if I go over to the row adjacent to the blue line, I should see infinite resistance, so it's an open. So I can also check continuity of my sockets adjacent to the blue line. So, whoops, I'm in trouble seeing there. So now I have my negative of my meter lead connected to the first socket on the power rail row adjacent to the blue line, and I'm also in the blue line here, so you can see that we're reading negligible resistance. So we've confirmed that our power rail sockets are connected the way we thought, and we can go ahead and make sure that our circuit build rows and columns are also connected. So I'm gonna test row 20 here. So basically, if I plug in anywhere along row 20, I should get negligible resistance, which I do. And if I plug into something in another row, say row 23, open. And I can do the same if I come over to row 20 on the other side. I also get an open. So that's confirming that for this particular protoboard, this channel in the middle is an electrical separation. And I can also confirm that, for instance, the rails on one side and the other are or are not connected. So blue is not connected to blue across the protoboard, even though they are connected on the same side. My finger out of the way so you can see. So we can, last but not least, we can check to make sure that this break in the line, in the colored line, indicates that we're not connected electrically on our power rail sockets, and so we could basically have a whole different, maybe a different battery or a different power supply connecting the other side. So if we connect these two, we're seeing an overload in spite of the fact that these are both connected to sockets adjacent to the red rail. Because there's this break, these are not connected electrically on this particular protoboard. But if I brought them both down on this lower half together, you can see we have negligible resistance. So if I want to build a circuit and I want to take, for instance, a jumper, or maybe I'll use a component, and I wanted to connect it between two rows, I put a resistor there and it's connected between, it's kind of hard to see in the perspective there. It's connected between rows 25 and 29. I could come over here. For instance, if I were going to connect to a battery or a power supply, it's always good practice to bring your power in along those pre-made rails. That makes it simple. So basically I'm going to make like a little series circuit. Of course, we all know that our multimeter it is a bit of a power supply when it's in ohm meter mode. So if I were to plug in my meter, so I put my meter negative in this blue row, which should be connected to this hole of the jumper lead, which is now connected into the same row that I have my resistor plugged into. And now I've connected the other lead of the resistor out to the red power rail. So if I put my other side of my multimeter into the red, I should get a value that corresponds to my nominal 500 ohm resistor, which is what it's showing, very nominally. So that concludes this quick demo on how to use a solderless protoboard. Basically, find out which holes are electrically connected and which ones aren't, and don't be afraid to use your multimeter to test. And always use a single strand wire, not a multi-strand, or you won't get a good connection. And generally speaking, there are certain gauges of wire that fit very well. A smaller gauge will always go into the hole, but it might be a little floppy and not make a secure connection. Something that's too large of a gauge, too small of a diameter. Something that's the opposite, too small of a diameter, too large of a diameter, too small of a gauge, might jam in the hole and bend and be difficult, and might even break off or kink. So that's the only other thing that you need to be aware of. Otherwise, these are intended to make circuit board prototyping very quick, very easy. No need to use any soldering or adhesives or any kind of permanent methods. And they also help you do some troubleshooting, since you can put little quick leads in and make intermediate measurements with your meter or your oscilloscope anywhere in your circuit. So happy circuit building.